All right, this is the quadratic formula. So here's a summary of the types of solving quadratic equations to find the roots, the zeros, or the x-intercepts. So you could use a graphing calculator and graph the function and find the x-intercepts. You can factor them, use square roots, completing the square, and the next one now is the quadratic formula. So by completing the square of a standard form equation, you can get the quadratic formula. So the left side shows you an example of a quadratic equation where you complete the square and it converts it to our quadratic formula. You can use the quadratic formula to solve any quadratic equation that is written in standard form, including equations that are real or complex solutions. You can use completing the square to check your answer you get using the quadratic formula. So in this box right here is the quadratic formula. You do need to memorize this quadratic formula. You need to make sure that the equation is in standard form. So ax squared plus bx plus c equals 0. So that's standard form. And then this is the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The other thing on this slide says the discriminant is part of the quadratic formula that you can use to determine the number of real solutions. So this piece underneath the radical is called the discriminant. It tells you the number of real roots of a quadratic equation. So here's an example. Find the zeros of the function using the quadratic formula. So the first thing we do is we set the function equal to 0. Then we want to make sure it's in standard form, which it is. So we identify the a value, which is 1, the b, which is 3, and the c, which is negative 7. And now I like to write the formula down so it helps me to memorize it. So I'd suggest that you do that. So x equals negative b plus or minus the square root of b squared minus 4ac. And then be very careful here. It's all over 2a. And now what is we do is we go ahead and substitute the a, b, and c into the formula. So x equals negative 3 plus or minus the square root of b squared, so I'm going to substitute 3 in, minus 4, substitute the a in, which is 1, substitute the c in, which is negative 7, all over 2, replace the a with 1. And now we simplify using our orders of operation. So underneath the radical is that discriminant. So 3 times 3 is 9. Then we multiply negative 4 times positive 1 times negative 7, which is positive 28, all over 2 times 1 is 2. Then we again simplify the discriminant. So we get negative 3 plus or minus 9 plus 28 is 37, all over 2. Notice that this is not a perfect square, so it just stays as it is. And again, this is that discriminant, which we'll learn about in a little bit of how many real solutions it has. Example 2, solve using the quadratic formula. So we set the function equal to 0. And then we make sure it's in standard form, which it is. So we identify the a. So a is 4. We identify the b, which is positive 3. We identify the c, which is 2. And then we have our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we substitute the a, b, and c in. So we substitute the b in, we get 3. Substitute the 4 in, and the 2. Substitute the a in. Then we simplify using our orders of operation. Three times 3 is 9. Negative 4 times positive 4 times positive 2 is negative 32. 2 times 4 is 8. Then we simplify underneath the radical, the discriminant. 9 minus 32 is negative 23. So remember from previous lessons that when you take the square root of a negative number, it does not produce a real number. So we're going to separate that out into the square root of negative 1 and the square root of 23. So then our final answer is going to be x equals negative 3 plus or minus I square roots of 23 all over 8. This next slide shows you the importance of that discriminant and how many real solutions it can have. So the first one says b squared minus 4ac is greater than 0. So if you have a positive discriminant, you're going to have two real solutions. You're going to have two x-intercepts. So two real solutions. The second one is when your discriminant equals 0. You're going to have one x-intercept. It's going to have a repeated root. The third scenario is when you have a negative discriminant. Notice that you do not have any x-intercepts. So you have two non-real complex roots. So it says find the type and number of solutions given this equation. So we work with just the discriminant. So the first example is in standard form. We identify the value of the a, b, and c. And then we use our discriminant, b squared minus 4ac. So again, in our quadratic formula, the discriminant is underneath the radical. All right, so go ahead and substitute the a, b, and c into the discriminant expression. And then we simplify it. Negative 6 times negative 6 is positive 36. Negative 4 times positive 1 times 11 is negative 44. And then we combine 36 minus 44 is negative 8. So now let's look up in our chart. Our discriminant is less than 0. It's a negative number. So if we look at this scenario right here, that's telling us we have two non-real solutions. Because the discriminant is less than 0. It's a negative number. All right, the next equation is not in standard form yet, so we have to move that x squared to the left side. So we subtract 6x from both sides. Now we have it in standard form. So we identify the a value, which is 1, the b, which is -6, and the c, which is +9. We substitute it into our discriminant expression. Substitute -6 in for b, 1 in for a, and 9 for c. And then we simplify. We get 36 minus 36, which simplifies to 0. So if we look at our chart, when we have a discriminant equals 0, that's telling us we have one x-intercept. So we have one real solution. Because our discriminant equals 0. This last part just shows you the difference between 3 different functions and when you'll have one solution, 2 real solutions, or no real solutions. So if we look at the blue equation, notice we have 2 real solutions, so 2 x-intercepts. Look at the red one, we have 1 x-intercept, or 1 real solution. And then the last one, the green quadratic, there isn't any x-intercepts out there because it's above the x-axis, so we have 2 non-real solutions.